Hey, that works. Good afternoon. Last week I was in Spain doing the 2 days theory of a 5-day course on heat treatment for insect control, which is the minimum that we assess people need. So I've got now 9 minutes to give you just the briefest insight onto insect control and heat treatment in the property care sector. I've got a legal disclaimer out there because it's not us or our advice or equipment that causes problems, it's people that cause problems, and ignorance and a lack of understanding of just how much damage heat treatment can do to buildings. There's literally been millions of pounds worth of damage done by ignorant people over the last 25 years that I've been involved in doing this. So, what is heat treatment for pest control? Well, basically, 52 degrees on the insect for a temperature of 1 hour will kill all eggs, larvae, pupae and adults of insects. It works by denaturing proteins, and proteins and enzyme activity, if you look at the graph, stops at 52 degrees. And actually, the denaturing starts really from the low 40s upwards. Heat kills, as I said, by disrupting enzyme activity, but we're only talking about insect control here. We're not talking about vertebrates or bacteria or viruses. Fungi, moot point, we'll discuss later with the PCA. So, how do insects get hot? Well, the object is to get the heat transmitted from our heaters by convection to the material that we're heating up, whether that's timber, which is what we're normally talking about here, or food production machinery, which you'll see from our stands out there, to penetrate right through to kill the eggs and the beasts hidden therein. Now, in the laboratory, eggs are the most difficult to kill, and adults the easiest to kill because they're more complex. In the wild, the adults can run around and try and hide from the heat, and the eggs are stuck there on the substrate in which they are living. If you want to take issue with any of the target temperatures, there is a massive information on this paper. The targets that we have adopted have just been the sort of high end of everything, so we beat everything there. Now, heat treatment it requires an understanding of physics, and it's different from other forms of pest control. So the energy required to heat anything up is basically its mass times specific heat capacity of the material you're heating up times the temperature change. Okay, and you can see from this that compared to steel, which is metals, what we might be heating up for food production machinery, wood has got about sort of 5 times specific heat capacity, and obviously different woods are slightly different. So you do need more energy and more time to get the heat to penetrate where we want it. Furthermore, wood is complicated by having water in it. And as you can see from this, the latent heat evaporation needed for water takes a huge amount of energy out of any heat treatment. So if you're heating up moist timber, just as the sweat coming off our brow when we get hot cools our whole body down, the evaporation of just a tiny little bit of water, well, the evaporation of just the tiniest bit of water from timber, from the surface of timber, drags that energy from inside and can take heat from the core of the wood, which is where we want it. And of course, when we're measuring temperatures, which you'll see from our temperature monitoring systems outside, we have to drill right into the center of that wood to measure that the heat has got exactly where we want it to go. So management of water is absolutely crucial in and understanding the behavior of water, which is why I was so interested in the first presentations this morning. I'm going to give you literally nothing more than a picture of what heat treatment actually looks like. This is just from this Christmas. It's a Billionaires Mayfair Club. I don't recognise anyone here from being a membership there, but basically woodworm larvae were dropping out of this overhead cladding. They hadn't used kiln-dried wood. They'd just taken natural wood just as a facade. They weren't structural, and were dropping onto the food of the millionaires and billionaires eating below. So we literally underdrew all of that, cooked it overnight, drilled dummy blocks into the timbers and run heat into the ceiling above so we could sandwich the wood there. And if that hadn't have worked, I imagine we would have heard of it by now. So that was obviously very successful. And you can see here the heaters, and there's 3 of these 25 kilowatt heaters of ours, putting the heat into the area for the treatment. As with, I've mentioned timber is important, water is important. So if we see any cracks that are already there, we photograph them, put a line across the end or something and measure them to make sure there is no movement of cracks or any other damage, and that we've got evidence before and after to make sure there is no movement. One of our earlier heat treatments, this is Larnaca Water Museum. Our Thermokil systems are in 25 countries around the world now, and in Cyprus they do a lot of heat treatment of timber. And this was done over 3 days, just same sort of principle, heating up, putting temperature sensors into the thickest piece of timber in the corners where heat is less likely to penetrate, and then covering over the roof and doing it actually in 3 sections. We've been working with the PCA to try and understand, because we don't understand buildings. We're pest controllers, pest management people. So we need your expertise to work with buildings. And so we're having Steve and James came out to help do the measurements as we did some spot treatments here on a sort of damp cottage in Derbyshire. Here we're doing the stairs. There you can see a beam in the kitchen, which we've sheeted over. And you can see on the Smeg fridge there, the massive dummy block that we was using to measure the penetration of the heat at the furthest point from where the heat was going in. And I know somebody asked me just in the coffee break, what can we do about furniture? Well, the lady had brought woodworm into her house by a variety of various furniture she bought at antiques fairs or whatever, and managed to infest her house. At the end of the day, we get a graph, which gives us this. Somebody also asked us about churches. This is doing the roof of a church in Nottinghamshire over, I think it's 2 to 3 days this project was. The roof had already been scaffolding around it, so we had to sheet it below and top to contain the heat within the areas that we wanted. We've had a lot of experience through what's called ISPM 15, which is heat treatment of pallets. We make these converted kilns, and it's a different heat treating process for this, but here we have to reach 56 degrees for 30 minutes as an international standard for phytosanitary measures. And as you can see here, we have to sort of drill into the wood to make sure this 56 degrees is achieved everywhere for the 30-minute period. You're all familiar with health and safety assessments. Part of this was my trip to Camp Bastion in Afghanistan, where all of our pallets for the troops coming home had to be heat treated with one of our systems that we'd built there. And there on your right is the health and safety clothing required for this visit. And the briefing started with, in the event of the air raid alarm, don your health and safety equipment and lie down by the nearest blast wall until the all clear sounds. So that was fun. We can also do this all over the world. This is in South Africa. We have heat treatment containers. So the actual knowledge of heating up timber is quite is not new to us. What is new to us is the effects on buildings. So we pick and choose our battles so we don't cause any damage, and touch wood. Thermokil Limited has never had any insurance claims to date, which is not the same for many people who've tried heat treatment, where some of the claims have gone into millions. So please, out there, do not be tempted to do this at home. As I say, we've been used to, this is hence my enthusiasm quickly on drying earlier. We use drying and reduction in relative humidity of houses to control fungus beetles, book lice, plaster beetles and mites, particularly in new build houses that haven't dried out properly. And Steve will raise a question of the balance between heat and ventilation later. That's an ongoing project. If anyone would like to partner us or sponsor research work, we are very open to discussions here. Next question is anything you don't understand. I wrote this 10 years ago. It's a snip at that, but you can pay me £500 a day to come and read it to you. There's a copy outside. Okay, am I within the time? Thank you.